Today we are on the fourth foray on this topic of conic sections. We're still on this very small topic of circles, looking at some of the very interesting properties that a circle does bear. Today we are looking at angles subtended on a circle. And looking at their properties. So I hope you hang around with us and see what we'll be looking at. So imagine we have points A and B from which these two lines are drawn so that an angle is subtended at point C. If this point C is moved around the major axis, that angle remains constant. It doesn't change. So what this essentially means is that at any point on that major arc, the angle subtended is going to be constant, or it's going to be the same. So let's assume we have 2 points C and D, from which point angle θ1 and θ2 are subtended respectively. We're going to show that θ1 and θ2 are equal. And let's begin by, first of all, showing that. So let's say we locate the center of the circle at point O, and we draw a line from O to C, and from O to A, and from O to B, right? Which is interesting to see that OC and OB are equal, so we have an isosceles triangle. So the base angles OCB and OBC are going to be equal, phi1 and phi2, and also OC and OA are equal. They are the radii of that, the radius of that circle. So this angle OAC is going to be phi1 minus θ1. And what that means is that we're going to have this angle here, which is 180 degrees from this triangle, minus phi1 minus θ1. Now this angle is vertically opposite, and so it's going to be equal. So our angle of interest that we're going to see subtended at the center, we'll call it x. So x plus this green angle plus phi1 minus θ1 is supposed to be equal to what? 180 degrees, right? So, which is interesting because now we find that x is equal to 2 θ1 from that exercise. So in other words, the angle subtended at the center is 2 θ1, and that means that we can also do the same for θ2, right? So if we go ahead and locate our center, O, and we draw lines OA and OB, and then we produce the line from point D up there through O to the circle, it means we've created another isosceles triangle where DO and OB are equal. So let's denote that psi1 and so psi1 being the base angle. What that means is that this angle here from the extreme end of the circle to O and B is going to be 2 psi1. And equally, this triangle on the opposite side is isosceles, so we see here we have θ2 minus psi1, so this angle at A is going to be θ2 minus psi1. And so this other half of the angle subtended at the center is going to be twice θ2 minus psi 1. So the total angle subtended at the center is going to be 2 theta 2, which means that this angle subtended at the center is twice theta 2, which is also equal to twice theta 1. So what that means is twice theta 2 equals to twice theta 1. Therefore, theta 1 is equals to theta 2. And that proves our assertion that any angle subtended at any point on the major axis, or the major arc, is the same. So that really covers what we wanted to look at today. I hope you had some fun following along. If you have any questions, please feel free to reach out to us. Until next time, bye-bye. It was an absolute pleasure sharing this with you.